Hey everyone, in my last video I tested printing PLA and PETG with different support materials, but with those combinations the prime tower kept failing during the print, and in Orca Slicer there isn't any option to use more than one prime tower. And when I skip using a prime tower, the results turn out pretty bad. The reason for using PLA or PETG as support material is so you can set a really tight gap between the support and the print wall. That way the surface comes out smooth without needing extra sanding. So I've been looking for a workaround that lets me keep using PLA or PETG as support material with zero gap while still maintaining good surface quality when swapping two heads. As you can see on the build plate, I made two cubes. The one on the left is PETG, which is the main printing material, and the one on the right is PLA, used as support material. In this video, I will show you how to set up those two cubes so they work as separate prime towers using the Snapmaker U1 3D printer. Next, we take a look at Orca Slicer's beam interlocking feature for joining TPU and PLA, which was suggested by one of this channel's viewers. And finally, we check out the Panda Sense Pro, an air quality monitor designed for 3D printer rooms. It's a DIY kit that requires some 3D printing and assembly. This is the same handlebar I tried printing with tight gap supports in my previous video. Once I reorient the model, I will enable 3 support. By default, the slicer sets a 0.2mm gap between the support and the wall. When you set the top C distance to 0mm, the gap gets tighter, which makes the wall surface under the support smoother, but it also makes the supports harder to remove, so you will probably need a material with lower bonding adhesion to the print, like a PLA or PETG combination. And when you turn on support ironing, the surface underneath the support comes out even smoother. Now I'm setting the support filament to PLA for both the base and the interface. By default, a prime tower is generated because the two heads need to swap and some filament has to be purged before printing the main part to ensure better surface quality. As I scroll through the layers, you can see the prime tower alternating between PLA and PETG. Since they don't adhere to each other, that's why the tower fails. In the multi-material tab, there is an option to print the outer wall of the prime tower with a single material. If I select PLA and enable the wipe tower, the outer wall will be printed only in PLA. But when I scroll through the layers, the inside of the tower still purges alternately between PLA and PETG. That's what causes the tower to fail, since there is no option to purge with a single material. So why do we scroll up to the very top layer of the prime tower, layer 258, which shows a height of 51.65mm, and I make sure to note that number. Next, I will disable the prime tower and move back to the Prepare tab. Right-click, select Add Primitive and select a cube. You can either use cube or cylinder. Under the Scale command, uncheck the Uniform Scale, and I set the size to 20 by 20mm, and for the height, I set it to 51.65mm, the height of the prime tower. Then I use the Ctrl+C and Ctrl+V to copy the cube. Right-click and change the filament to the PLA. Click on the object. Select your print from the browser and drag it down to the bottom. The next step is to make the printer follow the order from the object browser list on each layer. Click on Others tab. In the intra-layer order box, select As Object List. After slicing, you can see the printer will now print each object on the build plate in the same order they are arranged in the object browser. Here, the PETG cube is printed first before moving on to the main object. Same for the PLA in the green color. This approach lets the toolhead purge filament before starting the actual print, and since it purges on the tower with the same material, the tower won't fail. After the toolhead swap, the printer will first print the cube, then continue with the main object. Unlike the prime tower, this method makes the printer travel back and forth one extra loop before starting the next toolhead swapping. For this part, the print takes about 15 minutes longer compared to using the prime tower. You can clearly see that all the defects are contained on the cube while the main print remains unaffected. And here's the reason the toolhead can't go straight to the print after swapping, it still needs purging. The support came off easily just as I expected, and the surface looks as smooth as possible with support ironing enabled. On the print side, the surface looks smooth, however there are some black spots from the TPU I printed earlier since I didn't run extra purge when loading the filament. Here's how it looks from the support interface. Because this approach takes longer to print, in my next project I will try using the specially made support interface material for PLA and PETG. It's from bamboo and costs $35 for half a kilogram. I only need to use it for the support interface. And with multi-toolhead printers, there is no waste from purging. That's why I think it might be worth trying. I also ordered the ABS version because when printing card trims in ABS, I usually have to do a lot of sanding. With a multi-toolhead printer and a dedicated support interface, this can significantly reduce post-processing time. Next, let's look at the beam interlocking feature, which automatically creates a locking mechanism between different print materials, in this case TPU and PLA. Without interlocking, the two parts rely only on wall adhesion, which is very weak. Even if they are made from the same material, they can break apart with minimal force. From the multi-material tab, enable the beam interlocking option. By default, the slicer generates extra walls that extend into each other by 0.8 mm. These interlocking walls aren't visible on the top or bottom layers, so they don't affect the appearance of the print. If you need extra strength, set the boundary avoidance value to 0 mm. This will extend the interlock all the way to the top and bottom layers. When printing TPU95A on the U1, you can bypass the 4mm filament tube and go straight to the 6mm one. I have tested it and it works perfectly and no dragging issue. It may look a bit odd, but this particular TPU doesn't work with the 4mm tube. With this level of interlocking, I don't think it will come apart easily. This result comes from the default setting where the interlocking layers are buried 2 mm beneath the topmost layer. But as soon as I bend it, the topmost skin separates. This option might work with harder filaments, but not with the TPU. Next, let's test the fully interlocked version. So far, nothing has come apart as I bend it. After repeated bending, the bottom layer facing the build plate has peeled off, but the top layer remains intact. Next time I try printing the TPU with 100% infill to see if that resolves the issue. Right now the 5mm pin joints are holding up very well with no signs of peeling or separation. This is Panda Sense Pro, an air quality monitor designed for 3D printing rooms. BQ sent it to me for review. The device consists of TVOC sensor, formaldehyde sensor, CO2 sensor, and PM 2.5 sensor. And this one is temperature and humidity sensor. It's a barebone system priced at $89 and you will need to 3D print the casing, which consists of 5 parts. I will include the download link in the description. Because I printed in 3 colors, the total print time was about 5.5 hours. Here's the front facing part. And I didn't use multi-material supports since that would take far too long to print. I printed this casing at 45-degree angle and the default support settings already produced good results. For POA, I didn't feel the need for multi-material supports when the filament is dry. Support removal is already easy. This small button prints very well. And here's the back cover printed flat on the build plate. And this is all the waste generated by the Snapmaker U1 when printing in color. First insert the LCD ribbon into the connector like this, then pull down the lock lever. Then attach the temperature sensor to the main board. Then insert the LCD monitor into the opening in the casing. Then insert the trigger button and use the included screw to secure the main board. There are 4 screws. Next, attach the front facing part and secure it with 4 screws. Next, insert the temperature and humidity sensor into the bracket and fasten it with a screw. And here's the final part, the back cover. And there is no power button, so you need to plug in with the USB-C cable to power it on. The TVOC value takes about 5 minutes to display. The humidity today is very high, 72%, so I need to dry the filament before printing, even with the PLA. The TVOC and formaldehyde value will jump up when I print with the ABS, in which I will show you in the next video. Alright, thank you guys for watching. I'll see you in the next video.